quantum computing, in simple fashion to say, it's a kind of computing method which uses something called quantum technology and quantum mechanics. It uses quantum technology and quantum mechanics for the process of processing the data. Okay, so what does this quantum technology is all about? Quantum technology is nothing but it's a kind of emerging technology which uses quantum mechanics. Okay, so quantum technology uses quantum mechanics for its work. So here again, what does this quantum mechanics consist of? Quantum mechanics consists of some quantum principles, like let's say it consists of some quantum principles like quantum superposition and quantum entanglement. Quantum superposition and quantum entanglements, these are nothing but the two principles that are present, that are with respect to quantum mechanics. Okay, one principle is known as quantum superposition and other one is nothing but quantum entanglement. Okay, so in simple fashion to say, what is quantum is all about? Quantum is all about is refers to, usually if you want to study anything, you will study from the matter's perspective. The quantum physics, it tries to study the, if we talk from quantum physics perspective, so usually this quantum physics, it studies the behavior of the particles, behavior of a substance at subatomic level. This is the key thing here. That means quantum physics is a branch of the physics which tries to study the behavior of a substance at its subatomic levels. That means when you take up any matter, like usually if you take up any matter, let us say solids, a matter would be made up of various molecules. Okay, and these molecules would be further made up of various atoms. Okay, and these atoms would be further made up of some subatoms or subatomic particles. So these subatomic particles would be like, for example, like electrons, protons, likewise subatomic particles. So what does this quantum physics says is that when you look the nature of the matter or behavior of a substance at subatomic level, that means at this level, it will have a kind of unique behavior. That unique behavior can be explained with the help of these two principles. Okay, so one principle is quantum superposition and other one is quantum entanglement. Okay, so here when we talk from the perspective of this quantum particles or quantum physics, usually when we talk from normal particles or normal matter point of view, usually matter or substances will follow Newtonian laws, Newton's laws, like Newton's laws of gravity and Newton's laws of motion. Are you getting? So generally any particle, if we talk from the perspective of particle, so they will follow Newton's laws. So Newton's laws means R, Newton's law of gravity, Newton's laws of motion, likewise. But if we look the matter at this level, at quantum level, they won't follow the Newton's laws. That means they won't follow the Newton's law of gravity, they won't follow the Newton's laws of motion, likewise. Rather, they will follow something other else called quantum principles. So what are that quantum principles? One is this quantum superposition. So what is quantum superposition? means quantum superposition means when you talk from the perspective of this, the subatomic particles, the matter at subatomic level, usually it behaves in a different manner, where generally the particles will exist either in 0 or in the form of 1 in terms of digital or binary expression point of view. But if we are looking at the subatomic particle level, the particles at subatomic level, they will exist in multiple states at a time. Multiple states at a time. That means if you see within an atom, generally it would be represented either in the form of 0 or in the form of 1. This would be this is how matter would be represented. But if you look at subatomic particle level, the particles will be represented by existence of both 0 and 1 format simultaneously at a time. So such kind of unique behavior of the particles at subatomic level is nothing but quantum superposition. They are getting superposed. Position, they are getting superposed. And here, like for example, how we can say, just take a coin and toss it. When you look, when the toss is just flipping, so at one point you can see both head and tail quickly. Head and tail quickly. That means at that position they are superimposed that you cannot differentiate which is head and which is tail, which side is head and which side is tail. That means they are superimposed. That means they are existing at multiple states at a time. Are you getting that? That means at that quicker pace we can see that one. In the similar fashion, like at the subatomic particle level, we cannot represent the matter either in 0 form or 1 binary digits, 0 or 1 form, rather both of them will exist simultaneously. That process is known as superimposition. Okay, and in the similar way, like we can have something called quantum entanglement. What is quantum entanglement means? According to entanglement, quantum entanglement, two or more particles at subatomic level will be intricately interlinked to each other so that they will act as mirror images of both at subatomic particle level. In simple fashion to say, for example, like if I am showing this, so can you say which hand is this? Right hand. So how you are able to say that this is the right hand? How you are able to say this is the right hand? Because yes, in simple fashion to say, it is intricately interlinked to other part that when you just show them, both would be the mirror images of each other. Now you just look like this. So it is a mirror image of this and it is a mirror image of this. When you see likewise, for example, this is one thing, and now both of them are mirror images. And in the similar fashion, at the subatomic level also, the particles, like for example, if you are taking any electron, let's say this electron would be intricately interlinked to other electron in very closely that it will act as a mirror image of each other. It will act as a mirror image of each other. And at subatomic particle, as I have said you, subatomic particles will have a unique behavior that even if you separate them by longer distances, like let's say for example, you just keep it on this classroom, let's say you are keeping it on Earth and you just take this to space, you keep it on moon, and then also what happens, if you make any minor changes for this, then similar kind of impact or similar kind of change can be seen in this particle also. That means at subatomic particle level, the particles would be closely interlinked with each other, so that even if you take them, take them to any long distances, impact on one will have changes over other also. Likewise, so this kind of studies have been done in 2021 by 3 important scientists who have got Nobel Prize in 2022 for their quantum physics. Okay, so from that point of view, this topic was topic of news. And in 2023, there was a question asking qubit. Usually, if you talk from the computer point of view, the data would be just stored in the form of bits. Okay, but the quantum physics, in quantum computing, we will count or calculate the data in the form of qubits. We'll calculate the data in the form of qubits. Okay, so that's where the question has been picked and asked. Simply, recently the term qubits was in use. It is seen in with reference to what? Likewise. So we have got the 3 scientists have proven that at this level, if you're just taking this to even at longer distances also, there would be an impact of one on another. To justify this, what explanation they have given was that, in simple fashion to say, think from the perspective of Big Bang theory. Big Bang theory. Now think about the universe. How universe has been developed? Through Big Bang theory. That is one of the probable and justifiable source, we can say, for origin of the universe. That means at one point of time, the entire universe was made up of a small singularity, so one small atom. And when it became with infinite density and infinite thing, so then at one point of time it got a bang, so with that it exploded and universe has been formed. So the scientists have proved from their experiments point of view that this is the link, because everything has been originated from one single source. So due to this, quantum particles will work likewise. Okay, there were 3 scientists. You mentioned the name of the 3 scientists. One is John Classer. John Classer. And second one, you mentioned like a Alain Aspect. Alain Aspect. And third person, it is Anton Zeilinger. Anton Zeilinger. So these are the 3 scholars who worked with respect to this quantum physics and proved this quantum entanglement and quantum superposition. So for their contributions, they got Nobel Prize in 2022 for physics category. So that was one thing.